Azure, in which I have done no code machine learning. And in this case, first of all, I'll go through how to create my Microsoft Azure workspace for machine learning. So in this case, first of all, what we'll do, we'll first create an account. I have already my account. So after logging to the portal, what we have to do, so this is Azure portal, we have to create a resource. Here, I'm searching for a service that is provided by Microsoft. I'm searching here machine learning. So after clicking on machine learning, I'm able to create a resource in machine learning. And see, the first option here is machine learning, Azure machine learning. So I'll be creating over here. Just click it. And after clicking on this, we are able to set up our machine learning workspace, in which we have to provide the details like subscription. Give me a moment, it is just loading. So I'll create. So I have to give the subscription. I have free subscription, so I have entered Azure subscription one. This is a free subscription for like 30 days, in which I have received like 200 credits USD dollars. And this is the resource group. The resource group basically tells us all the things which are related to a project in one place, so we can easily identify for which subscription we are using a particular resource. Similarly, I can give the name of my workspace, the region in which I have to create my workspace, a storage account. So for my project, I have used ADLS, that is Azure Data Lake Storage, in which the data is stored in the hierarchical format. And after entering all these basic details, I have just created a Azure Machine Learning. So when I clicked on Review plus Create, I am able to go to the Machine Learning portal, which I have already opened here. In the Azure Machine Learning Studio, I have given my workspace name as ML project. So in this case, first of all, I'll go through this portal. So there is a home page in which I'm in this is by basically my home page, and this is next is AutoML. So here I can create models without any coding by using the automated ML features. Next is designer. Basically, I can use here drag and drop feature or interface to create and run machine learning pipelines. After that, in the data, I have my datasets where I can manage and explore our datasets. And there is an experiments here. Uh, these basically these jobs or experiments where we can run and track our machine learning experiments, and the pipeline where I can manage my machine learning workflow. So for this project, I have first uploaded my data into the data assets. I have clicked over here and I have uploaded my data using create button. So I have given my name as a data set as gen 1. So I have done all those things. So this is my data gen 1. We can see our data by clicking on the name of the data set, and we can go here jobs. Okay, so this is what this is showing. This is showing me the how many files I do have in my data sets, and total size of the files in the data set. Yeah, here in the explore button, I'm able to see the type of data I do have in my data set. So I do have like 7 columns here: data time, date time, plant ID, source key, DC power, AC power, daily yield, and total yield. So I have uploaded my data over here, and and in the designer page, I am able to see the pipeline that I have already created. So I have clicked on this pipeline. So this is my pipeline. So this is the overview how my ML Studio workspace works. So Gen 1, I have given the name of the dataset. So this is basically my data source, which is in the CSV file. So I provide the raw data that will be used for the machine learning pipeline. After that, I have selected the columns in that data set so that only relevant columns for the analysis will be used as a training. So and this basically done so that I am able to increase the model performance and reduce the computational overhead. After that, I have given this output to the split data. Split data basically split my data into two types: training set and the data and the testing set. I am doing so because I am able to evaluate the model performance by training one set of the data, which is known as training set, and testing on another set of data, which is known as testing set. So the model basically learns the relationship between the features and the target variable from this data in the testing set. In After doing so, I have chosen as a linear regression model, that is a machine learning model, to train my model. So this is my algorithm that I'll be using as a training and testing for my dataset. And I have given this output as an untrained model to the trained model module, in which this module basically trains the linear regression model using the training dataset and learns the training data so that I'm able to create a predictive model. So it receives input untrained model from the linear regression and training data from the split and the training data from the split data module. And the output that this module provides is ready for score model. And the score model uses the trained model to make the prediction on the training dataset and evaluates the model performance by scoring the model on the data it hasn't seen before. And the output of this model, I have provided it to the evaluate model. So it assesses the performance of the scored model and provides some matrices and visualization so that I'm able to understand how my model is performing. So this is basically my workflow of machine learning algorithm. After running this, I am able to see the performance of my model. So this is my output that I have received. So in this case, the best algorithm that works for my dataset is voting ensemble. Here, the results that I have received from this model are displayed here, that I have received from my machine learning model. So first is explained variance, which is 1, and it means the variability in the data that is captured by the model. So 1 means it is the variability in the data works perfectly, and MAE is 298.26. It gives how much error on average is in the prediction. And the main metric here is R square and root mean square, which I have received as R square is 1, which demonstrates that my model explains all the variance, confirming its accuracy. And root mean square is 466.93, which is basically reflecting the model overall magnitude, error magnitude. So these are the results that I have received for my ML model. And this is defining the regression model that I have used. So the primary metric that I chose is normalized mean square error, which I received as 466.93. And I can show the different models or different child models that I have run. So these are the different child models that I run on my datasets. So in the last, I can say that in the linear regression, I'm able to receive two different metrics, which is root mean square and R square, and I am able to show how my data set is performing, how my machine learning model is performing on generation 1 data. Thank you so much.